Now let us see a problem on wave equation. And in wave equation problems, we always assume that the string is tied at both the ends. So the condition u0 t is equal to 0 and ul t equal to 0, that is a common condition because that's a basic assumption that we make on the string. But the string may be set to vibration by giving a potential energy or a kinetic energy. So either the initial position of the spring from which it is released will be given to you, or the initial velocity applying which the string is getting vibrated will be given to you. Okay, so let us see a problem. A tightly stretched string of length L is initially at rest in equilibrium position. If it is set vibrating by giving to each its points a velocity lambda x into L minus x, find the displacement of the string at any distance x from one end and at any time t. So you are asked to find what is u x comma t. What is given as the string is initially at rest in the equilibrium position, means it is at rest. Now we are giving a velocity to each point to make it vibrating. So what is given as g of x has been given to you. G of x is the initial velocity, and that is nothing but lambda x into L minus x. Okay, and the string is initially at rest in equilibrium position, means the spring's initial position is the dead position, that is the equilibrium position. So your f of x is basically 0 here. Okay, so f of x equal to 0 and g of x equal to this, and you need to find the displacement of the spring. That means you need to find what is u. So to solve this, let us take the general solution of the wave equation, that is uxt is equal to sigma n equal to 0 to infinity an cos n pi ct by L plus bn sin n pi ct by L sin n pi x by L. This is the general solution of the wave equation under the assumption that both ends of the string are tied to some fixed. Now f of x equal to 0 means you get the expression ux0 equal to 0. That means you put t equal to 0 here, so the left side is becoming 0. So 0 is equal to sigma an sin n pi x by L, as explained in the second part of the solution of wave equation. So the left side is a series which is equal to 0. So this coefficients can be obtained as the coefficients given by the Euler formula. So an is equal to 2 by L integral 0 to L 0 dx, because the function f of x is 0 here. So if you integrate 0, you are going to get 0. So it is from 0 to L. Length of the string is taken as L. Thus your uxt becomes sigma n equal to 0 to infinity bn sin n pi ct by L sin n pi x by L. So this is your uxt now, because an has been vanished. Now we need to find what is bn. For that we have the second condition, that is the velocity is given to you. G of x is lambda x into L minus x. So ut x0, you have to put it as lambda x into L minus x. So lambda x into L minus x is equal to sigma 0 to infinity bn into n pi c by L sin n pi by L x. Now this is giving you the constants. This is the sine series expansion of the function lambda x into L minus x. So the coefficients can be obtained by using the Euler formula. N pi c by L bn is equal to 2 by L integral 0 to L lambda x into L minus x g of x into sin n pi x by L dx. Okay, so here you need to cancel this L and put bn equal to 2 by n pi c integral 0 to L lambda x into L minus x sin n pi x by L dx. So this you need to integrate. So you can apply the integration by parts and solve the problem. This can be taken as a bus function, and integration by parts give you the answer. It will be equal to 0 if n is even, and it is equal to 8 lambda L cube divided by n raised to 4 pi raised to 4 c if n is odd. So that if you substitute in the general solution, so your general solution to the problem becomes, this becomes 0, this an's are 0, so this term will not be there. In place of bn, you need to write 8 n pi, that expression, and sigma n equal to 0 to infinity. In this you have only half number of terms, because almost all terms are vanishing. Even terms are vanishing. So that summation will be just sigma n equal to 1, 3, 5, etc. So that's going to be the solution of this problem. You will be having a stretched string which has been kept at an initial position like this. Initial position will be given to you, and so f of x will be given to you, and it will be set. It will be released from this position, and therefore the initial velocity g of x can be taken as 0. F of x can be taken as this function, and sometimes f of x need not be given like as a function. It will be just said that the middle point has been lifted to particular distance. So you can see that this endpoint is 0, 0, and this endpoint, if it is the middle, then it will be L by 2, right? L by 2, comma. This height also will be given to you, say 10 centimeter. Then you can get this part of the equation of the function. And for getting this part, you need to take the line connecting L by 2 and 10. So that will be, this endpoint will be L comma 0, L comma 0. So you get this function. So your f of x can be derived as the equation of this straight line, say some ax plus b type equation here, whenever 0 less than or equal to x less than or equal to L by 2. And this equation also you have to derive using the 2-point form of the straight line. So this will be some cx plus d, because it's a straight line. 0 less than or equal to x less than, sorry, L by 2 less than or equal to x less than or equal to L. Of course, this can be made in the shape of a spherical object or a parabola or something. In that case, you have to derive it accordingly. Okay. And once you get f of x as this function and g of x as 0, you can solve, you can find what is an and what is bn. If g of x is equal to 0, bn will be 0, and you will be having only an. An only you need to find. In some other problems, instead of giving this velocity as lambda x into L minus x, it may be given to you as the velocity is given as sine 3 pi by L x. Then what you have to do is you can think of the left side as a trigonometric series or a series of sines with all other terms as sines, zeros, and only one sine term is there, which is 3 pi by L x, sine 3 pi by L x. Then n is equal to 3 only is non-zero here. So you can compare the terms and write bn into, so here the coefficient of sine 3 pi by L x is 1, right? And the right side is having so many terms in sine, but all the other terms are 0 because only sine 3 pi x by L is there on the left side. So you can put bn into n pi c by L equal to the coefficient of sine 3 x by L in this side. So suppose it is 1, then this is equal to 1, and you can find what is b3. Here I am putting n equal to 3, right? Because this side it is 3. So b3 only remains. b3 is equal to L by 3 pi c. Such problems also can be seen. Of course, you can do integration and find the all the coefficients bn. But if the function, the initial velocity or initial position is given as a sine function, then you can just compare the terms and write the answer. What is b0, b1, b2, etc. Thank you.